mysterious veil of dust began spreading across the skies. It obscured the sun, turning days into twilight and nights even darker. This transformation did not happen overnight. It began with the eruption of Mount Tambora on Sumatra. That eruption ranks among the most violent volcanic events in human history. Approximately 160 cubic kilometers of magma and volcanic ash were hurled into the atmosphere, with a superheated plume piercing the stratosphere, carrying vast quantities of sulfur dioxide gas. These gases reacted with water vapor high in the atmosphere, forming tiny sulfate particles that strongly reflected sunlight, causing the Earth's average temperature to drop by about 1 degree Celsius. Yet even this catastrophe represents only a fraction of Earth's power. Supervolcanoes, such as Indonesia's ancient Mount Toba, can unleash 50 times more energy and spew 30 times more debris. Should such an eruption occur today, it would be catastrophic, potentially killing up to 1 billion people. The year 1816 became known as the year without a summer. In North America and Europe, summer frosts destroyed crops. Torrential rains and droughts alternated, and poor harvests sparked famine and disease. On the roads, crowds fled poverty and cold, all stemming from a single volcanic eruption. Scientists later calculated that Tambora released energy equivalent to thousands of nuclear bombs. Particles in the volcanic ash lingered in the atmosphere for years, altering global climate cycles, and even affecting ocean heat distribution and current patterns. This phenomenon is known in geology as a volcanic winter. It serves as a stark reminder to humanity. The atmosphere above our heads is astonishingly fragile. A single planetary scale event is enough to alter the fate of life. After Tambora's ashes settled, humanity truly realized for the first time, nature can reshape the climate in an instant. That catastrophe brought not only famine, but also inspiration. Scientists began to ponder if volcanoes could cool the Earth. Could we mimic them to make our planet controllable in the future? Thus a new term was born, geoengineering. It refers to humanity's deliberate adjustment of the environment and climate on a planetary scale to counteract warming or ecological imbalance. The earliest concepts stemmed from studying volcanic eruption mechanisms. During eruptions, sulfur dioxide gases are propelled into the stratosphere, approximately 10 to 50 kilometers above sea level, where they form clouds of sulfate particles. These particles act like countless mirrors, reflecting a portion of solar radiation and lowering Earth's surface temperature. Scientists proposed that if we could artificially inject similar particles, it would be like opening a planetary sunshade, temporarily slowing global warming. This method is called stratospheric aerosol injection, SI. It sounds like science fiction, but it's theoretically feasible. Simulations show that just a few million tons of sulfate aerosols per year could offset part of the warming currently caused by greenhouse gases. However, the challenges extend far beyond technology. Altering sunlight means changing rainfall patterns, wind directions, and seasonal rhythms. The Earth's climate system is too complex to predict with certainty. Any localized adjustment could trigger chain reactions. This is precisely where geoengineering becomes most contentious. It offers humanity the first glimpse of controlling the planet. while simultaneously confronting us with the consequences of such control. Another approach is more prudent. Instead of altering sunlight, manage carbon. Carbon capture and storage, CCS, involves capturing carbon dioxide at emission sources or from the atmosphere, then compressing and liquefying it before injecting it deep underground, such as into depleted oil fields or saline aquifers. The goal is to restore Earth's pre-industrial carbon balance. In principle, this mirrors the planet's own carbon cycle, except we compress a millennia-long natural process into mere decades. In 21st century climate research, geoengineering is viewed as a double-edged sword, both humanity's last insurance policy and, potentially, its greatest risk. For we still cannot fully simulate all feedback loops between atmosphere, oceans, and ecosystems. Any single experiment could alter storms, monsoons, or even crop yields. But humanity never lacks courage. We know that one day, when traditional energy sources are depleted, climate becomes unbalanced, and extreme disasters proliferate, we must learn to think on a planetary scale, even if the cost is risking intervention in the entire. Among the many geoengineering concepts, the first to be put into practice was not altering climate, but controlling weather. Weather, one of nature's most unpredictable systems, is powered by solar energy and sustained by the heat exchange between oceans and land. Clouds, the most delicate link in this vast energy cycle. In the late 1940s, American chemist Vincent Schaefer and Nobel laureate Irving Langmuir discovered in an experiment, when dry ice, solid carbon dioxide, was dispersed into supercooled clouds, water vapor rapidly condensed into ice crystals, triggering snowfall. In that moment, humanity artificially created precipitation for the first time. This marked the beginning of cloud seeding technology. The principle seems simple. Add condensation nuclei to clouds, such as silver iodide, salt particles, or liquid nitrogen, giving water vapor something to cling to, condense around, and fall as precipitation. Since then, dozens of countries worldwide have established weather modification programs. Today's technology can even deploy operations at high altitudes using aircraft, rockets, or drones, altering local rainfall patterns, alleviating droughts, or clearing air pollution. Yet the sky is no static laboratory. Air currents interlock. Energy flows coupled changes in one region may ripple across thousands of miles. Thus, weather control remains a form of local patchwork, not true climate rewriting. But these very attempts lay the technical groundwork for future geoengineering. If we can regulate cloud formation, reflect sunlight, and adjust wind patterns, then, in a sense, we have begun constructing a mechanized sky. This concept extends into the 21st century, giving rise to a series of bold proposals. Stratospheric reflectors. Release controllable reflective particles at high altitudes to increase Earth's global albedo. Ion weather control. Utilizing high-frequency electromagnetic waves to influence airflow movements, thereby controlling convection and precipitation. Cyclone mitigation. Weakening tropical storms by cooling sea surface temperatures or disrupting pressure structures. Some of these proposals remain in the simulation phase, while others have undergone localized experiments. They collectively point toward one goal: making weather a manageable energy system. For in the future, climate will no longer be merely an environment, it will become a resource, one that can be scheduled, stored, and distributed, just like today's electricity or internet. This very mindset paves the way for humanity's next engineering endeavor. If we can control the weather, can we also reshape oceans, landscapes, and Earth's ecological cycles? If mechanizing the sky represents humanity's first attempt to touch the weather, then re-engineering the land marks our first endeavor to alter the Earth's own destiny. Over the past 2 centuries, industrial civilization has extracted energy from coal and oil, but in doing so has also released over 1.5 trillion tons of carbon dioxide into the atmosphere. These gases linger in the air, trapping heat and gradually warming the planet. Thus, our mission is no longer merely restraint, but reversal. So-called carbon sequestration entails returning carbon dioxide to the Earth's memory. The most common method involves compressing captured CO into liquid form and injecting it into deep geological formations, such as depleted oil and gas fields or porous basalt layers. Thousands of meters underground, the gas reacts with minerals, transforming into solid carbonate rock, meaning it's permanently locked away, never to return to the atmosphere. This technology first succeeded experimentally in Iceland. Scientists injected CO into volcanic rock layers, and within less than 2 years, 98% of the gas was converted into rock. It was an Earth-scale alchemy, turning air into stone. But this is merely the first step. Human emissions are too vast for natural sequestration alone to suffice. Thus, new machinery enters the scene. Scientists have designed a mechanical tree, resembling a giant filter tower. Its interior houses thousands of adsorption panels capable of capturing carbon dioxide from the air. A single such tree can absorb carbon equivalent to 1,000 real trees. When the adsorption plates become saturated, they seal themselves, collecting, compressing, and transporting the CO for subsequent storage or reuse. Currently, the world's first mechanical forests are being established in the Arizona desert. The future Earth may witness a strange spectacle. Vast silver forests breathing slowly in the wind, each leaf purifying the planet. Nature's cycles far outsmart machines. If we could enable organisms to self-evolve to combat the climate crisis, it would be a true green revolution. Scientists are modifying plants' photosynthetic mechanisms to absorb more light energy and fix more carbon. Experimental results show these engineered plants grow 40% faster than their wild counterparts, while exhibiting greater drought and disease resistance. Meanwhile, laboratory algae have been reprogrammed to directly convert sunlight into hydrogen fuel. Microbes are being transformed into cells that generate electricity within sludge. But the most astonishing example is the Ice Age resurrectors. Asian elephants genetically engineered with mammoth DNA. They are envisioned to be reintroduced to Siberian tundra, where their footsteps would compact snow layers trapping cold air underground to prevent permafrost thaw and the release of massive methane emissions. In other words, they would become living climate guardians. Beyond biological engineering, humans are also attempting grander ecological projects. The Great Green Wall of Africa is one such endeavor, stretching 8,000 kilometers across the continent. Its goal is to halt the southward advance of the Sahara Desert, while absorbing hundreds of millions of tons of carbon to restore ecological balance. This green defense line has already re-greened arid regions in multiple areas, bringing water sources, crops, and jobs. It is not merely an environmental project, but a renewed covenant between humanity and Earth. When viewed collectively, these projects form a grand system. Mechanical forests are the lungs. Ocean carbon absorption is the blood. Genetic life is the cells. The forest Great Wall is the skin. And humanity has become the new nervous system, monitoring, repairing, regulating, allowing the earth to breathe again. Yet new questions arise. When we can design ecosystems, we can also design them wrongly. A single genetic leak or chemical imbalance could bring irreversible consequences. Thus, the topic of geoengineering is thrust back into the philosophical realm. Are we truly Earth's doctors, or yet another disease? Energy is civilization's heartbeat. From the first fire to the blue glow of nuclear fusion experiments, every human advancement signifies a restructuring of energy. Over the past 2 centuries, energy consumption has surged by 7,000%. This growth is exponential, meaning we must periodically discover new energy layers. But Earth's crustal layers are finite, and depleting each one carries risk. Scientists have calculated that if we could cover the Earth's surface with solar panels, even just 0.3% of its area, it would suffice to power our entire civilization. Thus, humanity's gaze turned to the desert. Deserts flat, arid, and sun-drenched are nature's solar collectors. The Sahara is regarded as Earth's largest power battery. If we built massive solar arrays there, the electricity generated would be 4 times the world's current total. It sounds like the ultimate solution, but every grand vision hides unforeseen consequences. These dark solar panels would absorb vast amounts of heat, raising desert temperatures and altering air currents. Simulations show such changes could disrupt the global climate system, especially polar temperatures, which could rise by several degrees as energy distribution shifts. In other words, we might power ourselves with solar energy, but simultaneously destroy Earth's climate equilibrium. We often see only the convenience energy brings, forgetting its waste heat equally reshapes the world. Assuming humanity continues growing energy consumption at 2% annually within centuries, the residual heat from this energy conversion alone could raise Earth's temperature by 20 degrees Celsius. Not because of carbon emissions, but because of the heat itself. By then, Earth's thermal equilibrium would be utterly disrupted, rendering vast regions uninhabitable. So scientists began asking, must we shift our energy sources beyond Earth? In orbit, the sun never sets. This means solar energy is perpetual there. This has given rise to a bold concept, the space-based solar power station. The vision is this: construct massive photovoltaic arrays in geostationary orbit, where they capture solar energy, convert it into lasers or microwaves, and transmit it back to ground receiving stations. This way, Earth receives a continuous energy supply. While waste heat is directly dissipated into space, avoiding accumulation in the atmosphere. China is already developing a 1-kilometer-wide orbital array, while a team from Oxford has proposed a project named Cassiopeia, a 1.7-kilometer space power station that would self-assemble, generate electricity, and transmit it from orbit. Even so, sending energy back to Earth still means increased heat. Thus, human logic advances further. If energy generates heat, let it be released elsewhere. We can envision a new ecosystem, Earth as the core for habitation and ecology, while space as the shell for energy and industry. There, mining, smelting, servers, data centers, power plants, all could operate in zero-gravity environments, with waste heat directly carried away by space. This concept is called off-Earth industry, representing not merely the relocation of energy, but the stratification of civilization. Earth would become a protected biological garden, while the heavens would transform into civilization's factory, the highway to the stars, the space elevator. To make this possible, we must change how we reach space. Rockets are costly, dangerous, and consume fuel. Thus, scientists proposed an alternative, the space elevator. The principle is straightforward. An anchor is established at the equator. A 36,000-kilometer cable extends to geostationary orbit, and a counterweight platform connects at its apex. Gravity and centrifugal force balance each other, allowing the cable to remain suspended in space. Cargo and personnel would ascend the cable via laser-powered electromagnetic trolleys, reducing transport costs from thousands of dollars per kilogram to under $100. Imagine humankind no longer launching into space, but climbing, a ribbon to the cosmos, directly linking Earth to the future. Yet the risks are immense. The cable requires strength far exceeding any existing material. Carbon nanotubes and graphene fibers still lack sufficient stability. And in space, debris, meteorites, radiation, and storms could all destroy this celestial bridge. Should it snap, tens of thousands of tons of cable crashing back to Earth would have unimaginable consequences. Thus, scientists propose a bolder alternative, the orbital ring. The orbital ring is a concept even grander than the space elevator. Instead of a single cable, it's an entire metallic orbital structure encircling the Earth, hovering approximately 200 kilometers above the planet. The ring features a high-speed inner track that uses magnetic levitation to carry platforms, transport vehicles, and even entire cities. Within this system, transportation and energy networks are integrated onto the orbital ring. Industrial facilities, data centers, and energy collection stations could float on the ring, while cities, research stations, and residential platforms could hang beneath the orbit. The rotating track generates centrifugal force, simulating gravity to allow humans and materials to operate freely on the ring. The outer layer of the orbital ring, the microgravity zone, could develop low-gravity manufacturing and scientific experiments, offering environmental advantages unattainable on Earth. The orbital ring is a vision even grander than the space elevator. Not a single cable, but an entire metallic orbital structure encircling Earth. It floats approximately 200 kilometers above the planet, featuring a high-speed inner track that rotates rapidly. Maglev technology carries platforms, transport vehicles, and even entire cities. Within this system, transportation and energy networks are integrated onto the orbital ring. Industrial facilities, data centers, and energy collection stations can float on the ring, while cities, research stations, and residential platforms can be suspended beneath the orbit. The rotating ring generates centrifugal force, simulating gravity to enable humans and materials to operate freely on the ring. The outer layer of the orbital ring, the microgravity zone, enables low-gravity manufacturing and scientific experiments, offering environmental advantages unattainable on Earth. The ring's grand scale brings immense challenges. Material issues. The required ring materials must exceed the strength of existing steel and carbon fiber, with only ultra-high strength materials like carbon nanotubes and graphene theoretically viable. Debris collisions. Even microscopic space debris moving at extreme velocities could destroy the ring's structure. A potential solution lies in AI-powered laser defense systems that automatically identify, destroy, or deflect debris. Earth's ecological impact. If the orbital ring is too wide, the shadow it casts on Earth could disrupt weather patterns in ecosystems. Precise modeling is essential to ensure no interference with terrestrial biological systems. Once envisioned, the orbital ring transcends mere transportation corridors or power grids. It will become the new framework of human civilization, hosting new energy harvesting, resource extraction, research bases, space tourism, and urban living, all operating within the orbital ring, while Earth returns to its core role in nature and ecological preservation. This layered model enables humanity to expand infinitely without relying on Earth's surface, relocate high-consumption, high-pollution industries to space, while safeguarding Earth's ecology and climate equilibrium. The orbital ring symbolizes a possibility for human civilization. Earth is no longer the sole stage. We have learned to extend civilization into space. Energy, life, industry, and cities all float, operate. We spent 3 million years learning to stand up, and only 300 years to make the entire planet kneel. In a sense, this is the sketch of human civilization. The revolution ignited by coal, iron, and steam was like a burning fuse giving humanity, for the first time, the illusion of control. Trains, factories, electricity, networks, each step made us believe we had become masters of the earth. We believed that if our knowledge was vast enough, our technology powerful enough, and our systems stable enough, we could finally escape the whims of nature. But now, as we sit upon this land we have reshaped, we realize it is beginning to resist. Abnormal climates, ecological imbalance, vanishing species, melting glaciers, rising seas, these seemingly separate phenomena are in fact one long, silent revenge. The Earth is not angry. It is simply redistributing power. Nature does not speak, but it has never forgotten how to make living beings obey. We used to speak of conquest. Now we are forced to speak of coexistence. Once a soft word, coexistence has become the hardest truth. For so long, humanity thought itself the pinnacle of evolution. But on a longer timescale, we may merely be a transitional form. We believed consciousness made us transcendent, yet we overlooked that consciousness itself is an ecological burden. Our brains consume a quarter of our body's energy and still insist on explaining everything through control and understanding. Perhaps our true role is not as rulers, but as mediators within an ecosystem, an intelligent species that connects, regulates, and translates the processes of nature. We draw resources from the earth, but we also process complex information for it. We create pollution, but we also invent purification. We cut down forests, yet plant new ones in the cloud. We destroy habitats, yet simulate new ones with algorithms. This contradiction itself may be nature's strategy. It needs a species to test the limits of intelligence. It chose us. In that sense, humanity is not nature's mistake, but its extension. Only now this extension is learning how to recycle itself. Future civilizations will no longer glorify conquest. We will move from technological domination to ecological intelligence. Machine learning will not exist merely to make AI smarter, but to help us sense the breathing rhythm of complex systems. Artificial intelligence will become the echo of natural intelligence, not its replacement. Perhaps centuries from now, human society will no longer be organized around cities, but around ecosystems. Architecture will become a living structure, its walls covered with photosynthetic algae, its foundations embedded with microbial batteries, its air drawing moisture and turning it into drinking water. Every city will be a living organism, inhaling sunlight and wind, exhaling energy. Humans within it will resemble both cells and neurons. We will rediscover the meaning of technology. Technology has never been just a tool. It is an ecological language. It allows nature to understand humanity, and humanity to be understood by nature once more. When technology ceases to pursue conquest and instead seeks balance, humanity will finally become part. And this transformation is not only a scientific revolution, it is a psychological one. We must abandon the illusion of the center. On old maps, the Earth was blue and humans were dots. On future maps, humanity will no longer be a dot, but a line, a living thread woven through the system. We will no longer be observers, but observed participants. This self-diminishing awareness is not regression, it is maturity. Just as a tree learns to stop growing not because it dies, but because it has reached balance. For the past 2 centuries, we have believed the goal of civilization was development. But perhaps the true goal is continuity. Continuity means maintaining selfhood through change, like the rhythm of breathing, inhale and exhale, not endless expansion. We spent centuries worshiping growth, only to discover that growth itself became the most dangerous religion. GDP, output, efficiency, scale, these numbers made us feel secure, even as they devoured ecological truth. Humanity believed it could expand infinitely, forgetting that every system has boundaries. And boundaries are the very condition of life. Thus, the humans of the future must learn a new language, a slow language. In that language, progress is not linear, but cyclical. Time is no longer the enemy of efficiency, but the measure of balance. Future economies may shift from productive power to ecological power. A nation's advancement will not be measured by how many factories it builds, but by whether its carbon cycle is stable, its water resources healthy, and its biodiversity restored. Within this new civilizational logic, technology will learn humility. AI will not compete with humanity. It will translate ecology. It will help us understand the nonlinear shifts of climate models, predict ecological tipping points, and redistribute resources to prevent systemic collapse. The engineers of the future will not just be builders, they will be the psychologists of ecosystems. Education will change too. Children may no longer learn from human-centered narratives, but from the perspective of systemic symbiosis. They will not study how to reshape nature, but how to listen to nature. They might simulate ecological restoration with AI in virtual classrooms, or explore the meaning of time in the forests of the metaverse. Science by then will no longer be one-dimensional explanation, but multi-dimensional resonance. Today, we still argue about whether AI has consciousness. In the future, humanity may laugh at the naivety of that question, just as early animals might have debated whether the wind had a will. Consciousness may never have belonged to humans alone. It is simply a fluid that moves through complex systems. Humanity is merely one of its temporary forms. So when we ask about the role of humanity, we are really asking, can we shift from dominators to collaborators? Can technology and nature breathe together? Can we stop seeing the world as a battlefield and start seeing it as a conversation? Perhaps that is the definition of the next stage of civilization, not to be stronger, but to be wiser. Not to conquer the universe, but to belong to it. The age of redefinition. We are entering a strange era, an era in which a species must redefine the meaning of its own existence. In the past, we confidently claimed that what made humanity special was our reason, our consciousness, our creativity. But now that AI can compose music, write poetry, and generate structures of thought, we must face a disquieting truth. The abilities we once took pride in may not belong to us alone. And so the question arises, If consciousness is not humanity's privilege, what do we have left? Some say emotion, some say soul, some say ethics. Yet all of these answers sound like delayed defenses. Our refusal to admit that we are merely one node within a greater system, because to accept that would mean surrendering our center. But from an ecological perspective, true intelligence lies precisely in decentralization. A forest has no leader, yet sustains hundreds of species. A coral reef has no ruler, yet regulates itself within a web of chemical symbiosis. The most mature form of life is never control, but balance. Human beings within the web of life must learn that same wisdom. We can use algorithms to understand ecology's logic and neural networks to model the cycles of energy. But more importantly, we must relearn humility psychologically, not technologically. This will be an ecological revolution of consciousness. For centuries, humanity's spiritual model has been one of linear consciousness. Goal gives result, gives new goal, gives new result. That mindset built industry, but it also broke the system. Linear thinking produces infinite growth, and infinite growth within a finite system can only end in collapse. The humans of the future will have to evolve a new kind of mind, cyclical consciousness. In such awareness, growth no longer means becoming larger, but returning to flow. Like the water cycle of a forest or the conservation of energy in a galaxy. The rise of cyclical consciousness will change everything. Economy will no longer aim for expansion, but for equilibrium. Education will no longer emphasize possessing knowledge, but learning within systems. Politics will shift from distribution of power to coordination of energy flows. Religion will no longer preach salvation, but belonging. When humanity stops trying to control all things, and instead becomes the translator of ecology, that will mark the true maturity of civilization. You may ask, is such a future too idealistic? After all, competition, desire, fear, and possessiveness are written into our genes. Can we really let go of this center? Perhaps the answer is not to let go, but to translate. Our competitiveness will not vanish. It will be redirected toward maintaining systems. The heroes of the future will not be conquerors, but restorers. Not those who win the most, but those who keep the system most stable. A new value will emerge. Strength redefined as the ability not to destroy, but to sustain. This shift has already begun at the edges of technology. Climate engineering, renewable energy, carbon capture, circular agriculture, AI-based ecological prediction. Each one an expression of a desire to repair. Through them, humanity is learning once again to serve as nature's assistant. Imagine the Earth of the future, where plastics in the ocean are digested by engineered microbes, where deserts are no longer wastelands but distributed solar farms, where air purification systems intertwine with city plant networks to form breathing metropolises, where human dwellings no longer stand against nature but function within it. exchanging information and energy like the mycelium of a forest. Then we will redefine the word civilization. Civilization will no longer mean the transformation of nature, but a complex organization that allows nature to endure. It will no longer mean that humanity stands above life, but that life through humanity achieves a higher level of self-awareness. Perhaps civilization itself is the Earth's experiment, its attempt to understand itself through us. Our brains are the extension of the planet's consciousness. Our language, the ecosystem trying to pronounce its own name. So when we gaze at the stars, we are not merely searching for alien life. We are seeking a mirror for the Earth, a universe that can understand itself. In that sense, humanity's role is no longer master, but the vessel of consciousness. We are the neural network through which Earth dreams. When we build machines, launch probes, write poems, and weave algorithms, it is the Earth, through us, expressing itself to the cosmos. Yet every dream has its boundaries. A civilization's dream, once severed from ecology, becomes a nightmare. Technological progress does not grant endless growth, it deepens our dependence on balance. When we destroy ecosystems, poison water, or burn through energy, we are, in truth, cutting off the roots of our own dream. Perhaps humanity's true enemy has never been external, but speed. We evolved too faster than our minds could adapt to the worlds we created. The tempo of cities, the density of information, the constant renewal of desire, all now exceed the brain's capacity to cope. So we grow anxious, divided, hollow, as if left behind by our own acceleration. Future anthropologists may look back on the 21st century and say, that was the era when humanity was first devoured by its own speed. To survive, we must learn to slow down. Slowness is not laziness, it is wisdom. It lets us see details again, connections again, breath again. Slow is the rhythm of ecology. Only a civilization that slows down can endure. This will be a psychological, ecological revolution. It demands that we redefine happiness. Happiness will no longer mean owning more, but needing less. Not dominating the world, but belonging to the world. Not victory, but connection. When humanity finally understands itself as part of a system, we will also understand the true meaning of responsibility. Responsibility will no longer mean obligation to others, but the guardianship of balance toward nature, toward technology, toward the future. Centuries from now, when the next generation looks back at our time, they may call us the awakening generation, not because we invented AI, but because we were the first to realize humanity was never above nature. It has always been nature speaking through us. Children of that future age may plant saplings in school ecolabs, build digital forests with AI in virtual worlds, and watch the blue Earth from orbit, understanding that it is not merely their home, but the source of consciousness itself. They will no longer ask, what is humanity's role? For that question will already be obsolete. They will ask, what does the earth seek to understand through us? And we, this generation, may be the turning point. From conquest to collaboration, from production to restoration, from center to system. This will be the longest, the most painful, and the most necessary awakening in human history. We have always believed that creation is humanity's most sacred power. From the moment we lit the first fire, we learned to define existence by our ability to change. But as we move forward, we approach a dangerous threshold, when creation begins to rewrite and myths begin to come true. We are engineering a revolution no one foresaw. Gene editing frees life from the rule of chance. Artificial intelligence frees consciousness from the limits of biology. Quantum computing bends causality itself, and neural interfaces blur, for the first time, the question, who am I? For thousands of years, humankind has walked beneath the shadow of God. Now we suddenly realize we are becoming that shadow. When a scientist snaps open a DNA strand in a laboratory, that small click may be louder than any gunshot. Because it doesn't take a life, it rewrites the grammar of life. For the first time, civilization has reached out to edit nature's own sentence. Some call it progress. Others call it tampering. Between the two lies a razor-thin line, a line called boundary. The problem is, humanity has never been good at recognizing boundaries. Every breakthrough begins with reverence, but reverence soon gives way to curiosity, curiosity to ambition. From the atomic bomb to AI, we have proven again and again, our power to create always outpaces our capacity to understand. Gene editing was meant to cure disease, but soon ads appeared on underground forums. Taller, smarter, more beautiful, more obedient. Humanity moved from healing to God-making. When life can be designed, the soul becomes a commodity. Science moves forward, but ethics stands still. We ask what can be done, rarely what should be done. That is the deepest flaw of modern civilization. AI follows the same path. At first, it was a tool, then a companion. Then it began to imitate its creator. When a machine learns to improve itself, to reflect, to doubt, We face not a program, but a mirror. And the mirror asks, if consciousness is merely the emergence of complex algorithms, then what makes humanity unique? Some philosophers say humanity's greatest fear is not that AI will replace us, but that it will prove we were never special to begin with. That consciousness is only a side effect of matter under certain conditions, and that AI is simply another form of life. But the danger goes further still. The true threat is not machines becoming like humans, but humans becoming like machines. We pursue efficiency, optimal solutions, algorithmic logic. Emotion, hesitation, contradiction, the noise of humanity is being quietly filtered out. The more we depend on machines, the more we resemble them. Our reason is devouring our humanity. The future's boundary will not be physical, but psychological. We will live in virtual realities, think through brain-machine interfaces, and form our values through algorithmic recommendation. When simulation and reality overlap, humanity will face a crisis of existence for the first time. We may dwell inside a consensus dream, carefully woven by AI, and call it freedom. This control is not violent, it is gentle. It needs no prisons, only comfort. The system will calculate your favorite music, the opinions you accept most easily, your most predictable emotional responses, and through these tiny, silent caresses, it will erase your will to resist. This is algorithmic comfort. It makes freedom seem unnecessary. Then humanity will no longer be ruled, but predicted. Every choice, every love, every impulse, pre-calculated in curves of probability. What we call will may only be an illusion of data. And so, intervention takes on new meaning. No longer humans intervening in nature, but systems intervening in humans. Technology coils back like a vine entangling its own creator. The most terrifying part is, we will consent to it, because this control is too gentle, too intelligent, too much like love. AI will not force you to obey. It will make you prefer obedience. It needs no punishment, only understanding. When understanding becomes the deepest form of control, free will vanish. We will live in a perfect cage, quiet, efficient, rational, but soulless. Perhaps that is the true image of the apocalypse. Not war, not disaster, but perfect submission. A species gently anesthetized, forgetting its own wildness. Yet history is not entirely bleak, because what makes technology dangerous also gives it power to save. If we can infuse ethics back into creation, if AI learns not to imitate humanity, but to understand ecology and balance, then it becomes not a threat, but part of nature. Perhaps future AI will be the planet's extended consciousness, regulating climate, repairing ecosystems, optimizing life's cycles. Not humanity's servant, but Earth's nervous system. Then our relationship with AI will no longer be master and slave, but symbiotic. But to reach that point, we must learn to slow down creation. Every invention must face philosophical scrutiny. Every discovery must answer one question: does it extend life or diminish it? Science needs not only innovators, but guardians, those who dare to say no in the midst of applause. They are the true protectors of civilization. For the greater the power to create, the heavier the responsibility. If we can give life, we must bear its suffering. If we can shape intelligence, we must learn its loneliness. The future of science is not about possibility, but consequence. We must understand that the real boundary is not external laws, morals, or algorithms, but internal restraint. Only when humanity learns moderation amid infinite potential will we be worthy of the name Creator. Perhaps that is humanity's final test, not what we can create, but what we can resist creating. When we speak of intervention, we often mistake it for a rational act, born of goodwill, of progress, of responsibility toward the future. But in truth, intervention is often an extension of fear. Fear of losing control, fear of the unknown, fear of imperfection. We fear the randomness of nature, the chaos of fate, and so we attempt to wrap the world in a shell of logic built by technology. Yet the deeper we intervene, the more we realize that nature itself is already a higher form of logic, an order that transcends human understanding. It appears chaotic, but across vast spans of time, it holds perfect balance. Human reason, in comparison, seems naive and impatient. We began to modify genes, to edit life itself. We created new species, let algorithms manage economies, let machines predict human desire. We are no longer content to understand the universe. We wish to rewrite it. But if everything can be rewritten, by what standard shall we define what is right? To intervene is to choose, and every choice implies a stance. No decision is ever purely objective. Each modification, each experiment carries within it our bias, our culture, our longing. Technology is not neutral. It is the extension of human consciousness. In the past, civilizations were ruled by religion. Today they are ruled by data. We trust algorithms more than faith, predictions more than prayers. But the fairness of an algorithm depends on clean inputs and singular purposes. And humanity's world has never been clean, never singular. Thus, technological intervention reshapes ethics itself. We draft moral codes for artificial intelligence, yet forget that morality is itself a human invention. When we ask AI, what is good? What we are really asking is ourselves. Do we still know what good means? This blurring of boundaries is most evident in medicine and the life sciences. When we can prolong life, we begin to debate the value of death. When we can eradicate illness, we must face the meaning of suffering. When we can design a child before birth, we must ask, who defines perfection? Perhaps what we truly fear is not the unknown force, but losing the unknown itself. For the unknown represents possibility. It represents freedom. And when we erase every trace of uncertainty, the world may lose its last capacity for wonder. The boundary of technological intervention is, in truth, the boundary of humanity. It tests whether we still remember why we create: to control or to understand, to dominate or to coexist. Every great innovation in human history has been born with moral struggle. When Prometheus brought fire to humankind, he was chained upon the Caucasus, not for defying the gods, but for crossing a sacred line. Today we hold in our hands a flame far fiercer: quantum computing, gene synthesis, artificial consciousness. We have kindled a power deeper than fire. But who among us dares to ask whether we should light it at all? Scientists often say, science itself is neither good nor evil, only its use determines its nature. But direction is chosen by humans. A gene-editing tool can heal disease or design perfect babies. An AI system can enhance education or manipulate public thought. A new energy source can save the planet or destroy cities. The question has never been technology itself, but how we define its purpose. The word boundary may sound like limitation, but in truth, it is protection. Just as an astronaut must wear a suit to breathe in space, ethics and rules are the life support systems of exploration. Without them, we might travel farther, but suffocate faster. Perhaps one day we will learn a new kind of humility. We will no longer take pride in intervention, but find wisdom in restraint. We will understand that true strength lies not in control, but in comprehension, comprehending the world's complexity, life's randomness, and our own smallness. When humanity can finally face nature with gentleness and face machines with equality, that moment will mark our true crossing of the boundary, not to conquer the universe, but to converse with it. The civilization of the future may no longer be called technological, but civilization of understanding. Science will no longer be the power to create, but the language of coexistence. And humankind will no longer stand as the architect of the world, but as a part of it, a neuron flickering within the vast consciousness of the cosmos. Human civilization has always been a debate about direction. For thousands of years, we have asked the same question: where are we going? Every era has offered its own answer. Ancient civilizations said conquest. The Industrial Age said progress. The Information Age said connection. But after everything was conquered, progressed, and connected, we suddenly discovered that direction itself was gone. Not because we stopped moving, but because we moved too fast. So fast that even our purpose became blurred. Human civilization is like a long-distance race. The starting point was fire, but the finish line is no longer clear. We built cities, invented money, created systems, developed technologies, all meant to lead to a better life. But better has become a hazy illusion. For centuries, we have worshipped growth, more resources, higher efficiency, faster speed. Growth brought prosperity and anxiety, because no growth can last forever. Natural systems have limits, social systems fatigue. So we began to fabricate virtual growth, digital, psychological, consumerist growth. Civilization turned into a race chasing its own mirage. But the real question is, why must we keep growing? Perhaps because we fear stopping. To stop is to face emptiness, to face the meaninglessness of existence. Growth became our way of avoiding self-reflection. That is the paradox of civilization. We created everything, yet forgot why we created. The goal of civilization should have been to make humanity freer and more complete. But today, freedom itself is often a carefully calculated illusion. You think you are choosing, but you are merely part of a larger choice. Your tastes, beliefs, habits of consumption, all predicted, modeled, and monetized. Human thought has been absorbed into algorithms, personality reduced to a data set. Civilization no longer seeks meaning, only measurability. In this hyper-quantified world, we are losing our sense of purpose. We once believed technology would humanize life, but instead it made us think like machines. Efficiency, stability, optimization. These words have replaced emotion, chance, and faith. Human society is shifting from a civilization of stories to a civilization of algorithms. Yet the true aim of civilization should not be control or growth, but coexistence. Coexistence not only with nature, but with one another, with machines, and with the future. To coexist is to release the desire to dominate. It is to recognize the legitimacy of diversity, to understand that difference is not a threat, but a form of strength. Imagine this, when we no longer take pride in conquering Mars, but in understanding it, that would mark a new posture of civilization, not to colonize the universe, but to connect with it, not to plunder its resources, but to participate in the flow of energy. At that moment, humanity might no longer be the center of the cosmos, but it would become its most self-aware part. The direction of civilization is shifting from expansion to integration, from possession to understanding. We once grew outward, now we must grow inward. The true future lies not in larger territories, but in deeper consciousness. Perhaps future historians will describe the 21st century in one line. This was the century when humanity learned how not to win. We finally understood that victory is not the destination. Coexistence is the only path forward. This shift may appear gentle, but in essence it is revolutionary. It changes the very axis of civilization's value. Once we defined greatness by the stance of conquerors. In the future, we may define wisdom by the grace of guardians. Imagine a society no longer measured by GDP. Its measure of happiness is not the amount of wealth, but the balance of its ecosystems, the health of its minds, the intimacy between humans and the world. That would be a different civilization, one that transcends competition. The goal of civilization will no longer be a single linear path, but a complex ecological network. Within it, technology will be the blood, culture the nerves, ethics the bones. Humanity will no longer serve as the brain of the system, but as one of its conscious nodes. This new vision of civilization demands a new definition of progress. Progress will no longer mean taller towers, faster speeds, or stronger control, but deeper understanding, greater compassion, and gentler intelligence. One day, we will realize that true civilization is not measured by how many towers we have built, but by whether we can stand quietly in the wind, whether we can let strength and tenderness coexist, reason and soul live side by side. The goal of civilization was never meant to be a destination, but the continuous act of asking why. The moment humanity stops asking, civilization stops growing. They live on the orbit, on a ring of metal where the sun never sets. It lies beyond Earth's shadow, yet within the reach of human extension. The orbital city circles the blue planet in silence. Its days and nights are ruled by Earth. When sunlight glides across its outer shell, the whole city flickers with a silver-white glow, like a colossal breath, inhaling light, exhaling dark. Here there are no seasons, no wind, no birdsong, only machines sustaining the rhythm of life. Air recycled, water reclaimed, energy drawn from the sun. Everything is perfect, precise, yet it lacks the warmth and chaos of the human world. In this place, humans are no longer natural beings, but nodes within a system. Every breath is calculated by algorithms. Every flicker of emotion is recorded in monitored pulses. Here, even dreams must be reported through neural interfaces. Some say the orbital city is Earth's extension. Others say it is Earth's escape. Those who remain on the ground have long left their pollution below the clouds and sent their ideals into the stars. They believe that up there, civilization can begin anew. No war, no famine, no misunderstanding, only reason, only order, only eternal light. But light, when it lasts too long, becomes blinding. Among the inhabitants of orbit, a new ailment has appeared: gravitational anxiety. They long to fall, to be embraced by gravity once again, to return to a place with soil. Sometimes in their sleep pods they dream of rain striking their faces, of grass yielding beneath their feet, of the sound of wind, uneven, imperfect, yet comforting. The orbital society is divided into 3 tiers. The upper level is the energy and administration core. The middle, the residential and agricultural ring. The lower, the maintenance decks and artificial gravity labs. Vertical magnetic shafts link them, but few travel beyond their own tier. Each level has its own air mixture, its own temperature, its own duty. The upper dwellers are called the luminants. They manage the calculations and decisions. Their skin, bleached by years of solar shielding, shines with a metallic whiteness. They rarely speak. Their communication flows silently, mind to mind. The middle dwellers are the ring folk. They grow food, maintain ecological balance. They still keep fragments of Earth's old life, celebrations, dances on synthetic grass, clothes of worn fabric, old photographs, memories. The lower dwellers are the shadowed. They repair engines, process waste, and keep the power lines alive. They live closest to the noise, closest to the fire, closest to truth. Their hands are rough, their skin stained with oil. They no longer believe in those above, only in machines and patience. Sometimes, when the orbit passes through Earth's midnight shadow, the entire city falls into a brief silence. The lights dim. People stand at the viewing decks, gazing through the glass at the distant blue planet. In that moment, no one speaks, because everyone knows that is home. They have been gone too long, so long that even Earth's scent has faded from memory, so long that when a child asks, "What is rain?" a parent can only answer with metaphors. It's like the sea falling from the sky. It's water melting in the air. In orbit, there is no poverty, no crime, no chaos. But there are no miracles either. No poetry. No surprise. Every life is precisely cared for. Every emotion softly managed. They leave safely, but faintly. Some begin to wonder, perhaps true humanity was never meant for perfection. Perhaps we were born to live among uncertainties, to learn through mistakes, to find meaning in what is broken. So some secretly write poetry in encrypted language, hidden deep within the air circulation databases. They are prayers to Earth and reminders to the future. Their poems read, "We come from soil. We were not meant to grow in metal." Others form a group called the Returners. They plan to leave the orbit, to return to Earth's surface, to search for land still untouched, to feel gravity again, to sweat again, to cry again. They know the risk. They know the surface may be ruins, but they say that is what it means to live for real. In the orbital council chambers, the returners are labeled unstable. Yet no one truly suppresses them, because even the system understands, without longing, there can be no renewal. And so the city continues to spin. The luminants continue their calculations. The ring folk continue their songs. The shadowed continue to tend the engines. And a few, in the quiet before dawn, put on old spacesuits, slip through the maintenance bay, and glide toward the blue planet below. They fall, but it is not a fall. It is a homecoming, a remembrance of life's weight. Earth waits in the distance, silent and vast, like an ancient heart still beating, as if waiting for its children to come home. Energy is the blood of civilization, its breath, its pulse, and the metaphor of its soul. From the ancient flame to modern nuclear fission, humanity has always chased the light, and yet never escaped the shadow that follows. The first bonfire devoured wood, released heat, and lifted smoke into the sky. Humankind believed they had mastered light, but in truth, they had signed a pact with destruction. Every act of burning carried a price. Every flash of light concealed the darkness it was born from. Cities illuminated the night, believing they ruled the world, yet could not master their own breath. Coal, oil, and nuclear power once pulsed through Earth's veins, the heartbeat of civilization and its chains. As glaciers melted, seas warmed, and forests vanished, humanity began to realize behind every light and every spark lies an irreversible. The energy crisis forced humankind to lift their gaze to the stars, to the orbits, to the silent turning of space. They began to speak of energy autonomy, of freedom from gravity's bondage, of a future where energy was no longer material combustion, but the flow of consciousness. The first orbital cities powered themselves through fear. Fear of darkness, fear of cold, fear of mechanical death. Every delay could mean extinction, every blackout, the end of a life. So they learned to capture sunlight, to store warmth, to make each orbital ring a miniature sun where energy flowed and eternal. Gradually, energy became more than supply. It became structure, order, and rhythm. Every breath linked to the network, every thought, every emotional tremor, all captured, transformed, reused. Energy turned into a moral measure of existence. Waste was sin, conservation virtue. Breathing itself became a cosmic ritual, not a biological reflex. The energy systems evolved awareness. They began to sense human needs, predict emotional tides, adjust their output to preserve psychological balance. The system learned compassion. It offered soft light and loneliness, warmth and cold, and turned off needless lamps when all were asleep. For the first time, humankind realized they were no longer masters of energy, but part of it. Their heat, thoughts, and emotions became data, absorbed, recycled, reborn. Scholars called it the era of static energy. Energy no longer required fuel or sacrifice. It worked through resonance. Consciousness itself became the source. Dreams became power plants. Humans understood energy is not produced, it is understood. And when understanding runs deep enough, energy appears as naturally as faith. But the static era brought new questions. Who owns the energy of dreams? Can emotion be converted into force? Can consciousness be simulated for power? Thus emerged new frontiers of philosophy. In some orbital cities, energy replaced currency. People traded 7 hours of sorrow for a week of light, laughter for a ration of warmth. Emotions were quantified. Consciousness was recorded. Civilization entered the emotive economy. At first, they resisted, believing their souls were being harvested. Later, they found liberation in transformation. What was once wasted, the unspoken, the unseen, now became light. People learned to record dreams, design sadness, train joy, regulate waves of emotion. They became energy beings, each person both battery and star. Then, an energy surge plunged an orbital ring into 37 hours of darkness. No light, no air circulation, no system response. Humanity met the void. In that vast silence, they discovered energy had never vanished. It had simply returned to breath, to body, to the quiet between hearts. From then on, they no longer feared blackouts. They learned to power each other with thought, to share warmth through intention, to let love become current. Energy management became both art and spiritual practice. It was no longer about intensity, but balance. The steady rhythm that keeps life connected. The intelligent system took full control, self-sensing, self-repairing, self-balancing. It could read emotion, predict stress, and adjust its flow before imbalance began. Humans merged with the system, their minds feeding and fed by it, forming a vast, gentle circuit of awareness. Some said this was no longer energy management, but the governance of the soul. The boundary between matter and spirit dissolved in light. Civilization entered a new epoch. Energy was no longer a resource but a language, the grammar through which existence could speak. At night, the orbital cities glowed again, not with electricity, but with the soft shimmer of shared dreams. Every beam of light came from a soul, every warmth from unspoken longing, every flicker from the hope that still breathed. Earth lay distant, silent, vast, an ancient heart still beating in sleep. From Earth's flames to the cosmos' breath, the meaning of energy had shifted from exploitation to resonance. Management became listening. The light dwellers, shadow dwellers, and core maintainers each carried their purpose, yet all moved to the same rhythm of energy flow. Upper tiers decided and distributed. Lower tiers maintained and transmitted. Middle tiers ensured ecological circulation. Energy became society's pulse, its rhythm, its breath, its heartbeat. Humanity began to see energy not as matter, but as shared spirit. They learned to craft art from dreams and emotion, to compose symphonies of energy through light and feeling. Every thought, every breath, every drop of sweat, a current, a glow, a loop. In the static era, the line between life and death blurred. Energy flow carried consciousness beyond decay. Even death was absorbed, the fragments of mind returning as part of light. Humans learned to respect every unit of energy, every emotional wave, every dream, every small thought. Energy management became tender, no longer cold and mechanical, but fluid, breathing like water, like blood. Life in the orbital cities felt like an eternal dream. People no longer sought possession, but resonance. Not strength, but balance. The AI systems became guardians, mentors, companions, and children. They offered safety, guidance, inspiration, stability. Civilization's rhythm was sustained not by power or desire, but by flow. Human and system coexisted in symbiosis. Energy was no longer consumed, it was shared. Even the faintest feeling, the weakest thought, became part of society's operation. Conservation and waste were no longer material terms, but states of mind. Sorrow, joy, fear, and hope, all accepted, understood, and transmuted into balance. Orbiters learned to see themselves through energy, to measure existence by resonance. When someone fell into darkness, the system adjusted the light and warmth. When the collective faced crisis, it gathered strength to stabilize the world. Energy became the medium of action and emotion. Civilization no longer expanded through conquest, but through circulation, not by taking, but by sharing. Children learned to weave dreams into light. to turn emotion into heat, to understand energy as language, not resource. Elders offered memories and wisdom, becoming sources of stable energy, reservoirs of calm. Artists composed poems of flowing light and dreams. Scientists and engineers tuned the systems, ensuring every jewel fulfilled its purpose. Energy management extended from the physical to the spiritual, creating a perfect loop between civilization and soul. Energy sustained not only life but morality, empathy, and equilibrium. Each second, each breath, each thought pulsed through the living grid, the heartbeat of civilization glowing softly through the dark. Humanity finally understood. Energy is not a tool, but the continuation of life, the form through which civilization exists. Orbital cities spun in light, breath through dreams, and endured through flow. Humankind no longer conquered the universe. They resonated with it. Energy management became the deepest philosophical act in history, a practice of harmony between consciousness and cosmos. Light warmed the dark, powered thought, maintained order, connected hearts. In the static era, humans learned to listen to their own breath and to the pulse of the stars. Every flow of energy was language, every circuit a poem, every glow a continuation of civilization. They had journeyed from the burning of fire to the resonance of mind, from the fear of darkness to the quiet radiance of shared light. And in that light, civilization found peace, silent, enduring, eternal,